post it there.
Okay. Yeah. Let's view video. Oh, there's some other thing here on this page. It's nice. Learning a generative meta model of LLM automations. Oh, more people. Nice.
Yeah, so this tries to replace, or I'm not sure if you could say, it seems to be more than that, but part of it is it does something like sparse autoencoders, but you use diffusion instead of sparse autoencoder. And actually, I don't remember the exact architecture they do diffusion with. Probably just I see just MLP blocks. I don't know if they use attention. And it seems to have better some metric. I'm not sure if it's the same like reconstruction loss, some distance metric. So, and interesting how they call it generative latent prior, I think. Oh yeah, like that's it. Yeah, it can generate arbitrary activations. Also, that's another aspect. I don't. It's generative, so sparse autoencoders. Well, they can also kind of, yeah, like. So it can. It's like, yeah.
Okay. I mean, I guess my question is: Does this do? Like, is this actually better than sparse encoder, or like better for some use case, or is this one of those nice papers when something does whatever variant of sparse encoders that, like, a few months after, nobody cares or remembers about it?
They have some metrics to evaluate this apparently, and apparently it's a higher number, but I don't understand the metric to say like
Yeah, I
generally
think
it's better or not.
I guess we'll read a bit more. I think the problem is that will describe both an actually useful, replacement of other encoders and all of the other papers of things that didn't really pan out.
Yeah.
Everyone
Like,
has some metric where they say that they are better as post encoders at that metric, and the question is if that actually captures like what we really care about.
there's a Frechet distance to like I guess compare how distant is the latent prior from the actual model there, the actual activation ground truth, I guess. Yeah, and they say reconstructions are more off manifold than this one. So, like, also, I think I remember there was also something about the fact how in sparse autoencoders you have this inductive prior for more sparsity in the loss function, and here you don't have that, but it still is sparse by default. So like it's like let's just remove the inductive prior and it emerges on its own, and that's apparently better in some way. I don't know. I don't fully understand this paper.
Okay, so let me quickly. Existing approaches of analyzing neural networks, such as PCA and sparse encoders, rely on strong structural assumptions. That's true. Generative models of interpretability. They can cover starting without the sensors and act as priors that improve intervention fidelity. I mean, that makes me worry that they are doing the thing where you, instead of explaining the model, you are accidentally making things up for the same reason that you shouldn't. It's not usually a good idea to do a probe that's like a big net instead of a linear probe.
Like you can do it especially against linear probes.
Like apparently the latents are sparse, like in sparse autoencoders, and interpretable in a way like in sparse autoencoders, if I
maybe
remember
that
correctly.
We'll see.
Yeah.
I'm just saying it because it's like I think I want the paper to answer why it's not that, right? Why the latents actually represent what's going on with the network. We have some reason.
There is steering, so
training diffusion models. I mean, steering is so witness you are doing something info, yeah. From 1 billion residual streams activations creating meta models that less the division networks of internet states. Bitter lesson build.
yeah, just get rid of all the inductive priors, let it find its own.
Reliable predictability. Applying the meta models learned prior to steering interventions improves fluency with learning gains as loss decreases. Moreover, the meta models never increasingly isolate concept individual units. Although, to be fair, that if you want the one things to understand the model, maybe sometimes structural assumptions are nice because you then understand what it means for something to be a sports encoder latent or whatever. And I guess maybe here you can still extract it. But we'll read the method, but this feels like the kind of thing where you might have to do interpretability of the interpretability thing.
Like
yeah,
apparently it's still sparse. Oh yeah, they meta models neurons increasingly isolate concepts into individual units.
yeah, but
So
I
that still
mean, even
happens
if it's
apparently.
sparse, you have some sparse concept, and it's nice because I don't know, maybe it does work that you have this sparse concept and it's represented on the network somehow. But I wonder, like, what you can figure out from that, like, how that thing is represented on the network, or are you just abstracting yourself from that? But if you're abstracting yourself from that, seems like less Mech Interp in some way, but maybe it's still useful. Or maybe you can, in fact, figure it out. We'll see.
Like if it's still sparse, like sparse autoencoders, and if it's better reconstruction, which I don't know if their distance measures that, their metric, then this seems like better. But I don't know. Maybe reality has its advantages and disadvantages.
Okay, let's read it, I guess. Generative latent prior.
Also, maybe we can. This is a blog post. Maybe if you wanna read the paper,
Oh
or maybe
yeah, read the
first
paper.
blog post and then the paper.
I was briefly looking at the blog post first because they usually summarize things better.
Yeah.
Just to get
That works.
basically it's like skimming the paper first, so it can be useful.
Yeah.
By the way, for everyone else, it doesn't have to be just me and Purni talking. Other people can, either on voice chat or on, the text chat. Feel free to say things.
If you have
I
any
feel
thoughts,
like they could have. I'm surprised they use persona vectors here.
oh yeah,
They
looks
use
like they did.
persona letters. Oh, here. Huh.
Yeah, so if any of you has any thoughts, any questions, if you don't understand some part of it, any notes, like anything that comes to mind, maybe some other paper that's relevant to this, or you did something similar, or you've seen something similar, or etc. Feel free to just say anything.
Yeah, this is this is not the this is the reading group, not the Bernie and Victor podcast.
Mhm.
Yeah. actually, yeah, if you don't want to, you also don't have to.
I wonder how do they formalize fluency score and concept score.
This is interesting to compare with persona vectors, although people don't usually the persona vectors is not about the sparse encoder, right? I guess it's more on the kind of thing Neil says about how sparse encoders don't seem to be a lot more useful than linear probes and that kind of thing. And
Oh, so it works better. It makes it actually more evil.
maybe I feel like I wouldn't, for one example, it's not us. I wouldn't do too much based on one example of the text that they picked. But yeah.
Wow. It is different. It feels different when you read the examples.
Yeah, there might be different, directions.
Yeah. That's maybe also why. Interesting that they use the evil persona as an example.
It's kind of problem with GPL.
Oh, you can click on the evil persona and pick a different thing. Positive sentiment.
Oh, I see.
I was a very good student. Oh, they compare it with diff mean here instead of persona vector.
Do you know have we read this paper?
This one has been on my reading list for 2 years.
I don't remember if we did. We could read this one next for next week if we don't have other ideas. We probably should look into old but important papers that we missed on the reading group and we haven't done.
I really want to read the universality group theory from Neil one.
Okay, but that one we did read on the reading group at some point.
Yeah.
I would lie if I remember. I said I remember what. Maybe I should go watch my own video or something. But yeah, it's kind of problem with GPL. Anti-probing.
Deep and non-linear instead of shallow linear. This kind of also reminds me of the sparse transformers. Those are technically also deep and non-linear.
I think there is a reason why people use sparse that people use linear probes instead of non-linear probes, and I wonder if there is an analogous thing here that makes ELP or whatever sometimes bad idea, but yeah, let's see. I think I need to read the paper. Okay, let's understand this. Also, yeah, it scales. They show the typical scaling plot where loss is this, and then flops is x, but is as usual a logarithmic thing.
Uh-huh. Line goes up, or actually line goes down in this case.
Yeah.
I wonder if it could overfit if you do it for too long and so on. Yeah.
I mean, that when you are doing very big data sets, that's basically doesn't happen. You don't train it that long, right? Like, you don't have the compute to overfit really, really big
Yeah.
networks. If you do a small one, maybe to a data set with however much. Especially here, you can get as many activations you want from the model, right? So
Yeah.
I don't think impact is overfit.
Yes. I used to think these big models would overfit. Apparently, it's more complex. Yes.
The cases. I mean, it's just if you have a really big model and you have a big return over a really big data set, it's just you much easier for the model to find some generalizable thing than memorize everything. Not only
Yeah.
memorize everything, like it's also going to have a high, much higher norm, and the regularization is going to get rid of
Regularization
that. But
helps a
even
lot.
without the regularization, as you can see on the Crokin paper, all that still happens.
Mm-hmm. Original Cracking paper has a very strong regularization. Yeah. But yeah.
No, actually, if you increase the regularization, you don't get croaking because the model just learns the other circuit first, and you only get croaking when you fiddle with the regularization on the right amount. But there is also a version that they also show without regularization. It still happens.
Oh, I'm not sure if I've seen that one. I'm curious about that one. Yes.
I mean, I think that's also on Neil's paper.
At the end. Okay.
But we can talk about that later.
Yes.
Going back to this, is this yeah?
Yeah, I think that's the same
It's a
abstract.
diffusion model, language model activation, noise activation, the noise activation.
No way, this is a different abstract. No, it's the same abstract.
I mean, I think it is. It's a summary from, right? Yeah, I think the other one was maybe is it exactly the same test or?
It looks the same actually.
Okay. Okay, yeah, that doesn't matter. But I was looking at the image now. Okay, so I want to understand how this diffusion thing works exactly. What are they doing diffusion on?
Do you know generally how diffusion works?
Yeah, I mean, okay, so I have understand diffusion. You have some image. Normally, you're doing on images or whatever, and you have some image or some latents. But let's say you did it on the images directly. You take the image, you add noise, and then you train the model to undo steps of noise.
Yeah, that's nicely said. Yes, on a very high level, denoising it's called. Yeah.
But yeah, I'm curious. Because here,
Oh,
what are you? What
they
are
do
you
flow
doing?
matching here. Actually, here. I don't think they do just pure diffusion. I don't wait. Flow matching. Let me see. We use flow matching. Oh yeah, okay. So here they actually do flow matching, which is a general. Oh, you could, in one sense, it's a generalization of diffusion. So you transform the probability distribution from Gaussian to whatever is your target distribution. There was one great wait, I wanna find it. Visualization what flow matching is doing. Oh yeah. Here, I think this is the best intuition visualized.
Put it on
graphics.
put it on the chat.
Yes. Oops.
For everyone
Wrong.
else, Purni put it.
Also wrong.
Okay.
And now
Yeah,
fixed. Yeah. So like
put it on
you start with some initial condition from some noise, and then you either denoise it and flow matching instead takes this straight path in so you learn velocity fields basically, which transform.
So basically, it's the inflow march. You're still doing this process to the images where you.
Yes.
But
Each
you're doing
point.
a different thing. That's not
Yeah.
adding random Gaussian noise. You're adding a different kind of noise that makes it this flow. Like that you're doing something else to the image or whatever. Or the
Yeah,
data.
like each point here is part of the data set, and yeah, you have velocity fields in general, and there's a thing called Gaussian flow matching, which is basically equivalent to diffusion.
Okay.
So
But it's
yeah.
still the same kind of thing where you do a perturbation on the image and then you train the model to undo it. Like
Yeah,
multiple steps of a perturbation.
basically.
Okay.
I went. Yeah.
Do the new image models and all that use flow matching instead of diffusion?
Flow matching basically. How do you call it? What's the word? Replaced classic diffusion at this point. And now there's also a thing called, I think, rectified flow matching or something like there's a variants of flow matching which are like better because they just work better. Yeah.
Okay. So it's basically like Adam completely replaced doing great descent.
Yeah, it's it is, yeah. You just, the straight paths are just, they just work better somehow. Yeah.
I can see why they might work better than random.
But the new ones aren't straight. I think because you want better some curving math, whatever, which I still wanna go through. There is a lot of engineering. It's essentially physics. I think you could say it's like vector fields. It's like and in vector fields you have velocity. Yeah.
Measure determination of the method for determination of the I think this is funny for some reason. Determination of the measure for the determination of the measure for the determination of the measure.
Series last. Wait, let me see. Okay, I see here.
I mean, I don't think this kind of plot is very informative because they choose it, and we have to believe them that this person color does better than the thing, but maybe it goes better, yeah.
I believe there are tasks where this method will work worse than SAE, but yeah, I guess also depends on the trained SAE and the trained G. How do they call it? Generative prior, latent prior. They are trashing SAE too hard. Someone is writing in this chat.
I mean, I feel like do you with this person? Well, actually, I have some takes on this, but I feel like I probably should just first understand what the method is and what they say, and then start complaining.
Yeah.
Okay, let's try to figure this out. Okay, so they do flow marching. Nice. Training activation distribution model. Okay, so let's see first if there is some. Yeah, training diffusion model. They talk about how nice. Yeah, it's nice. It scales and whatever. Yeah. How does it work? Diffusion head, yep, tip. Continuous vectors, metric resources, yeah. Adequate diffusion. Yeah, yeah, we already know what diffusion is. This is. Yeah, display form matching. I think your explanation is better than. Yeah, but this is the same, but with more math.
Yeah, here they're explaining the flow matching.
Yeah. The most is to.
Yeah, target velocity. So that's those
I
velocity
will
fields.
demonstrate this. On what from what? On like the same kind of thing as person encoders, they do diffusion. No, I'm not sure. I feel like I still need some details to understand what they're doing. Like okay,
I think they. I haven't. Okay, like my. Okay, my guess so far is you take an activation, you just noise it, and then learn the model like denoise the activations to ground truth activations.
But doesn't that where does the where does the sparsity come in? Do you have like is it on the middle of the denoiser thing or what? I guess we can think.
I think they say somewhere that it's just emergent somehow. I might be wrong though. Yeah, I cannot find it.
So I guess they could be doing diffusion, and if it has a lot of layers, right? So, huh. Okay, let's. So architecture. They have as a stack of feed-forward MLP blocks from the string of Llama 3. I don't know what following the design of battery means expresses. It has a single layer. Okay, so this is lam like they could get the details of Llama state, but it doesn't have attention.
Yeah, it looks like there is no attention.
I mean, I wonder why that you could also do attention. You have the maybe it's easier to understand this way. You are already not going to easily understand what the thing is doing, so you might as well do a transformer maybe. But
like apparently it still decomposes into sparse concepts the weights somehow.
We'll see. Okay, we'll see that.
Also, in terms of all these diffusion things, just some new libraries just came out which try to unify all diffusion LLM, diffusion transformer. For I think that was in the context of LLMs though.
It would be funny if you had to train a person encoders on GPL to understand to get the features of the GPL. But okay, they probably have some sparsity somewhere. Okay, this is just details of how they train it, but yeah. The middlemost layer. They also train a multi-layer model, like the cross-layer transcoders and all that.
And they just train from the middlemost layer. Okay. Yeah, just like SAEs.
I think it's funny.
And inside.
Is it me or the questions we have are basically not explained already? Maybe they're explained later. Okay, maybe it's here. The reason is funny is they start talking about hyperparameters and all that. They didn't explain yet what what they are training it on, how it fits in the actual model and all that. But maybe they're here. Okay.
They say that they train it on middle layers of the llama. We always train on activations from the middlemost layer, layer 7 of llama 1b, in the data pipeline section.
I guess so. I guess they the foul thing that the main guess is they just trying to reconstruct activations and then they get the sparse representations in the middle somehow.
I want to see what's the input and output.
I mean, it can be the same. Maybe it's just the same as the sparse encoders, right? The input is the activations and the output is the same activations, and you're just. But where does the sparsity and all that come from, right?
I think it's somehow emergent. I also cannot find it. Like if they like table 4, I think. Table 4. Oh yeah. In table 4, binary concept from a single scalar feature GLP metaneurons substantially outperform all baselines. Hopefully the baselines are good.
I mean, I hope they compare also some things with. Yeah, they did. I like that they did the persona vectors and all that. I hope they did compare things like linear probes and all that, because otherwise I wonder. Like, there are some ways that sparse encoders are worse than other methods, and they are not very good, and the things that need complain about. And if you have a model that
here they compare with 1D probes.
Maybe. And I worry for this kind of method that is just doing this literally copy. There are things that you will do better than sparse encoders by literally copy pasting the activations. Yeah.
1D probing should be logistic regression. So input is the extract activation from the residual stream at a given intermediate layer. And they train on 1 billion residual stream activations from the fine web corpus. Okay. And the output is the target velocity for denoising. So at inference it generates activation samples via the reverse process.
Mhm.
And the generated outputs are activation vectors that are near indistinguishable from the real ones. Oh yeah. They use Frecce distance and PCA to check that they are near indistinguishable.
Okay.
Okay.
I wonder. I don't know how much it works. By the way, someone asks, what does near indistinguishable mean in this case? How does the Frecce distance shows that? Do you know? I don't know what the Frecce distance is.
I don't think they even explain in the paper, so we have to check that outside of this paper.
Okay.
That's
Maybe you can ask
yeah.
Roll while I keep reading this.
It has a wiki page. I'm gonna check wiki page first.
Okay.
Measure of similarity between curves. As a distance between probability distributions. That's probably what they're using. Like scale divergence is also something similar.
Why not use scale divergence though?
I don't know. That's interesting.
Wait, so
Usually it's used in images to compare generated images with real images, apparently. Alright.
initially disaster for the off manifold activation at an intermediate step.
And it's used to evaluate GANs or diffusion models generally. Okay. So this is not exotic, this is part of diffusion models.
Huh. Initially this from the off
But I never really did much diffusion. Interesting.
I'm not sure I understand this. Initialize diffusion sampling from the off manifold activation at the mid step. I do get that you can do cool things with the diffusion thing that you can't do with person coders.
What do you mean now?
Also, the darkness.
Initiate diffusion sampling from the off manifold activation. Of the manifold is just out of distribution, I think. I think they mean just you start with noise. That's what they mean by off manifold activation, I guess. Oh, rather than pure noise. Never mind. Okay.
What does it mean to initialize from off manifold activation? Do you have
Do they define off manifold? I think it's
okay.
just
So you have some activate steering thing that you want to add that you got with the typical methods. You got the steering, but you want to make it more like the normal activation. So you put it on the middle of the diffusion step and then do diffusion. That seems like it's actually could be pretty cool and useful.
okay.
Are not
Seems
useful
like
for
they
this
only
kind of
use it
things.
for activation steering. Have they used it for activation patching?
No, activation patching is a well. I mean, you could do activation patching with it. Yeah, never mind.
No, though. I'm surprised they only did activation steering on section 2.
Yeah, they just mean that if you add concept direction to activation, that pushes it off manifold. I don't know why they say off manifold. It feels like unnecessary jargon to me. It should be like out of or out of
Or not from the model.
training data. I know.
Yeah.
Yeah.
I'm assuming they mean not from the training data, but maybe they explain it somewhere.
I guess like if you sample all of the activations, that all of that forms a manifold, and then you just if you add concepts like this, then you get out of that manifold. I
Also,
guess.
to
That's
note
the
that
rationale.
people get rewarded by in the review processes conference for adding more jargon that the reviewers don't understand, so they don't feel like complaining about it. There's very perverse incentives in making your paper
Yes.
sound
What is
confusing
manifolds,
in a
anyways? In
smart
this
way.
context of this paper, anyways.
Manifold is a space that looks locally Euclidean, but globally it's not. So, like, if you have a donut and go that perfect donut in pure mathematics and go more and more and more, locally and look around. Our planet is also a manifold in a way. So, like, if you stand, everything looks flat. So then people think that Earth is
So
flat.
it looks flat when zoomed in, but not flat
Yeah.
when zoomed out.
Yeah, that's manifold. If I remember correctly. Okay, yeah. Topological space that locally resembles Euclidean space near each point. Okay, yeah.
It's
that's
like, is it
what I said.
like manifold, like more like the generalization of the intuitive concepts of like a surface or a plane or something like that?
The Euclidean space locally is important part. And
Yeah.
other shapes could have different. There's some function that's differentiable everywhere, but continuous nowhere, I think, or something like that. No, continuous
Yeah,
everywhere and differentiable nowhere. Like
that
that's not Euclidean locally. Yeah, not sure if you know. Yeah,
I guess it's more like the concept of a smooth surface or
yeah,
something like that. And that I seen an image of that one, and that one is.
yeah. I mean, yeah, it makes sense to use this term, but most people don't do that. Except from Francois Cholet. I think he says that, if I remember him correctly.
I mean, no, I feel like the manifold people do talk about manifolds a lot.
Oh yeah, there's there's the low dimensional manifold hypothesis, or how it's called.
Yeah. Yeah, no, I feel like a lot of machine learning papers use manifold. It's just here when they say of manifold, I think it's just confusion not because of they use the term manifold, which I do get to mean some, lower dimensional, space thing. It's more that when they say of manifold activations, like of what manifold and where do they come from, all that. Also, by the way, Daphne asks, so the distance between the generated activations and the real activations is very small, and how is distance measured in this case? Talking about the Frechet distance, I think.
Yeah, they just say they use it, and if you go to Wiki, then you see the formula, and you just take the hyperparams. You take if you do it between Gaussian distribution, you take the means, you take the covariance matrices, and just put them together. But like, I don't know how you do that for like general probability distribution though. I guess that's what you do in the Frechet inception distance. I guess that's what they try to do that here, because that's literally the use case. Yeah.
I'm curious about this one. Alignment between sparse autoencoders. Also, someone was writing but stopped. You feel free to just write and whatever, even if we keep talking. Improving sparse encoders. Improving the alignment between sparse encoders, steering and feature descriptions. Feature descriptions are derived from the sparse encoder. This is a lot of manifold. Let me say with encoder. Okay, what does this mean? Feature descriptions are derived from the sparse encoder. Yeah. While the content directions for stimulating derive from the sparse decoder. Yeah, makes sense. We want to see whether GPL can help in cases that the steering fails because the decoder directions are off manifold.
How do they measure off manifoldness?
So
If off manifold means it's off that flat area, right?
yeah, it's all. I think they are using off manifold to talk about they are not that the kind of activations that the model will normally have or something like that.
But like, it feels weird because if you like add a concept vector, like you cannot really know if what you produced is actually off manifold of that model. Like you would have to sample the whole activation space of the LLM, which is computationally
they
intractable.
are talking about. Okay, I think. Okay, so here they're talking about the sparse encoder decoder, right? So is it the case that the sparse autoencoder? Okay, how often it happens that you do, let's just say you do a steering on the sparse encoder, right? You take some feature from the decoder and you activate it, and that turns out that activating that feature writes something on the, maybe only with that feature. Like I guess I think that could happen. So normally, if on its own, you will assume all of the sparse encoder features are actually meaningful most of the time, right? Because you train the model to reconstruct using some sparse activations, so you there's not going to be perfect, but you should expect the sparse activations to mean something, but or approximately mean something, but I guess a way it could be off manifold apart from the fact that the sparse encoder might not be good is that you could have a feature that normally when that feature happens, like there is some other features that should be there, and this breaks the model. And I guess you could use GPL to do something with that. We apply GPL on top of the scope, first encoder. Select 500 random directions and grade the steer outputs and the feature description on Neuropedia. Okay. Random directions. How do you so they apply GPL? I guess that both of these cases are cases of, in some sense, like this is they talk about replacing protocols, but so far this is not about replacing protocols. This is more about this doing a nice thing you can do with diffusion, which is try to fix the activations and make them more like real activations. Like you do some intervention on the activations, and that maybe breaks things, and you then
That
do
makes sense.
apply the diffusion to try to make it more like real activations, right? And
Yeah, I see what you mean.
that's cool. That seems like it's a different tool than a sports encoder that tries to do different things that the sports encoders are trying to do. But maybe you can also use them for things to use normally use sports encoders.
Like I think this is the first part of the paper, and later they have the they look at the neurons inside.
Okay, yeah,
think.
we'll get into that. I just thinking that I couldn't see how this is clearly useful and something that works. That if getting a diffusion thing to work will be useful for other things, even if the other part that I'm more skeptical of improving of first encoders doesn't end up working that much better, right?
Mhm.
I say because I still don't understand I still want to understand where they get their sparsity from. Do they just trade a sparse encoder of the GLP? Which that was really kind of funny, but I guess we'll get into that. Just random directions. Also, by the way, if people are more interested in some specific part of the paper or want to figure something out, then you can tell me. Okay, I can go to there or something. Otherwise, I'll just keep going whatever in order. Or like if you feel like staying too much on some part that's not that interesting, just tell me. Wait, so let me quickly figure this out. So, random directions. On encoder decoder misalignment. I'm not sure why there will be encoder decoder misalignment. But okay. So okay, I guess I can see how the decoder could be using combination like the sparsity could. Oh yeah, I okay. I think I can see what the encoder misalignment. Should have to explain it easily, but with this split quantitative samples in double study for coefficients with comparable frequency scores, post processes with GLP evidence helps us steering better than much than prison. Okay, but yeah. So
1 billion tokens, I think, and 1 billion parameters. Holy shit, that's a lot. By this.
how much do people train sparse encoders actually? Like on how much activations? I'm curious about that. There's probably some of the papers we already seen that explain that, but we kind of skipped it because they weren't.
Guess depends how big SAE you want.
Yeah.
On how big model. And what parts of the model as well. And how accurate. Yeah.
Yeah. There's no easy answer which way.
And how general.
We evaluate GLP offsetting of broad interest, steering llama to exhibit certain behavioral traits. Diffmin is just doing the Diffmin is just doing the difference in being activations between two contrast sets. Yeah, I think that. And just I was not thinking of thermal. I don't think I read the thermal paper, but I think the Les Brown posts that where people come up with that. Like I think more or less at the same time. We post process. Okay, I think this is actually a very good, very nice idea and probably useful. Like when you do this diff mean thing, you do the difference mean. A problem with that is that you break the model in weird ways because the model normally doesn't have this. You're adding this difference of activations on top of the thing that doesn't have to make sense or like correspond to a thing the model will normally do, and you often have to pick very carefully like the strength of the how much the scaling of the vector or something, and you still probably mess things like some things that depend on the norm of the activations and things like that. But with this that doing I can see why doing diffusion steps on top of that should help. Seems very neat.
It makes sense since the model learns like to push arbitrary activations toward in distribution activations basically.
Yeah.
So
Like, I
yeah.
think so in general I think this diffusion thing might be a nice tool for that. For you have some weird intervention or something you can to do with the model and you want to push it towards in distribution activations, and maybe that fixes things.
Yeah. Also,
Maybe
there's more to it later in the paper.
Yeah.
The meta neurons.
Listen to persona. Yeah. Okay, same kind of thing. You have the persona vector, and you try to improve it by doing that. I don't know. Okay, they say they have 7 constant scores. 5 constant scores. Better than GPL. Yeah, this is nice. Yeah. 1D probing. Predictive. Okay, this is then they are okay. Interpreting with GPL. This is the part that I'll read. I'm initially skeptical of. Show that GPL can be figured as a feature encoder via 1D probing, where a single scalar feature is used to predict a binary concept. We use 1D probing to use its latest concept into single units with more conventional.
I'm worried about so it turns one human feature into like activations, but like how do we know the feature already exists in the model? I guess if they're testing
Yeah,
the model.
it's the same kind of
Theory.
thing as the
Like it could be like the model feature exists, but it already existed as like a multiple features.
Yeah, or is something you can deduce from the data, and the model wasn't actually tracking that concept or something. I see there's a lot of people now. Hi. I said it earlier, but since there is a bit more people, we are reading, mostly me are only talking about the paper, but anyone else feel to talk or like write something on chat at any point and interrupt us.
Yep. If you have any thoughts or found similar papers or ideas or notes and so on.
And also, I also like how much it's better than. Okay, we are interested in comparing performance of provisioners with other purpose. Yeah, but so the problem with this, I'll read it more, and maybe I'm wrong, but I think the problem is that sparse encoders are not that good at the reconstruction in some sense, but they are sparse. And how much, if you want to do probing, if you're doing probing on the GPL, how much are you? Is it better in some sense than doing probing on the model directly? Because there is a lot of things where it seems like probing on the model directly is better than probing on the sparse encoders. So, right. So maybe the GPL is just learning the same kind of representations the model learns, but we don't want to just have for this kind of thing, we don't want to just have the same kind of representation model learns. We want to have some more sparse thing that is easier to understand. And they talk about meta neurons. Let's see what that is. GPL with meta neurons or internal representations of the meta model instead. We instead this blocks regulate. What does that mean? Are they just doing probes or what? From our concept, we use the We ran probing into 2 stages. We first used the heuristic from Gurney et al. To find the small sets of candidate news using the train set. Then fed I'm not sure what was this paper. Sparse probing. Also, it's a sparse probing paper. I don't know if we read this paper. I think not. But yeah. Okay. Fit logistic classifier on the 1D features using this. We only fed 1D input for the lessons. We use L2 regularization, which is statistical and sort of thing. All probes are conducted on the last token activations. It's sequence. Also, it is wait. What 1D? What is 1D classifier? Isn't is just
I think
a
that
probe,
I
linear
think
probe,
so.
but with fancier math, fancier terms.
Yeah, 1D classifier.
Yeah, like it's not the thing that people normally call a linear probe of that concept.
So 1D classifier is just logistic regression, I think, right?
Yes,
No?
that would be my guess. Do they explain it anywhere in the paper?
No, wait, it's 1D probing.
Yeah, they say we fit logistic regression classifiers on the 1D features. So they say logistic regression, yeah.
Okay, yeah, so fancy term for that. So wait, so do they? I'm understanding correctly. Maybe someone else can, but do they just? Sorry, I kind of lost what I was from. Do they just train probes on the GPL, and that's their interpretation thing?
Meta interpretability.
But like, do they are they doing the thing I was complaining about earlier, where they might have to interpret interpret the GPL, and then they have to do probes, and maybe they'll train as part of the encoder on the GPL, and what are we even,
Let's train sparse autoencoders on GPL.
You train a GPL on the GPL, and then you.
I was thinking about that. Could you train GPL on GPL?
The thing is GPL training the probes on GPL better in some way than just training them on the model directly? If so, why? Is my question. 1D probing. Yeah, I'm curious about the baselines they're comparing to. Okay, first. John Gonzalo was here and he knows about a lot about sports encoders, but he left. I wanted maybe to ask him things, but okay. Meta-neurons discovered by 1D probing. We start vaccine bioactivation samples of the corpus. Wait, sorry, I kind of getting lost. Strong, I'm kind of tired. Indicating the LLM that some nativity style helps us external code. Best encoder for what the problem? Raw layer A output. I'm confused about this thing. Like, of course you do probing on. Okay, I can imagine it could not work like this. But we do know that probing works, right? Like doing probes on models works. So of course, the sparse encoders that are reconstruction work worse than probing on models, and yeah, the GPL is going to work better than. Okay, this is the interesting thing. The GPL outperforms Llama raw activations. So they are trying to. They're saying that maybe GPL is better. I think that's kind of sus. Maybe, but yeah.
So is it the case that they are doing 1D probing on like GLP activations and SE activations, and they are comparing the two? Is that the case?
I think they are doing that. I'm not completely sure because they are using a lot of weird terminology. But that's my current understanding. If someone else thinks I'm wrong, tell me. But yeah.
I'm also a bit confused.
Yeah, to when I start the meta neurons discover why they're probing, which they just right. It doesn't make sense if they are just training the probes on the model, right?
Yeah.
And here they say, yeah, they are strong, indicating that native disentanglement. Yeah, of course. We do know that models have different representations that are separable linearly. The whole linear representation hypothesis thing. I guess you could imagine that the TPL could have things more separatable where the linear representation hypothesis is not completely true and there are some nonlinear things and maybe that, but the GPL has nonlinear layers and all that, so I don't know why that will be the case. Is that kind of coincidence sometimes? I guess you could do a thing. Unless the Sigulu gates or something do something to that. I don't know all the fancy activations. But there are kind of things that people do where there are. I hadn't thought about this, but there was a kind of research that didn't pan out where people try to make things that make changes that make models more interpretable without getting a lot of performance loss, right? On training, right? Changing something at the architecture. You could do that, like do this kind of diffusion thing or something, and you try to use methods like that on the diffusion thing to make it learn more interpretable representations of the activations.
You mean sparse transformers, for example?
Yeah, things like that. I think the sparse models things that Leo Gao did is actually the same kind of.
Yeah, the sparse circuits one.
And they were doing that, like they were also doing the same kind of thing where they train a meta model on the other model, but it has some more sparsity. I guess it's an extensive. Just GLP doesn't seem to have done any sparsity or anything, right? So you should expect it to be as
They
interpretable as the
say
base
they
model.
do.
They haven't made a GPT-2 yet.
Where though?
Yeah, I guess
Okay, maybe explain more later, but oh no, the paper already. Yeah, this is already related word, so they don't explain more later unless it's on the appendix. But here it seems like the sparsities, not the sparsities, they just train probes, linear probes on the GPL, right?
Yeah, so
Looks
the,
like.
the idea is not to get like features. The idea is to just put it back to the manifold, like project it onto the manifold.
Yeah, I mean, I feel like they're doing a thing here where they interpreting with GPL thing. That's the thing that I don't feel like it's super. It's kind of meh because it's. I guess the idea is more. Maybe turns out that the base model doesn't learn the kind of representations that you can find with linear probes because it doesn't represent linear things linearly or something, and then we you use the GPL and turns out for whatever reason it's easier to find features there with probes. Like probes work better on the GPL. It's just that's not true. Like the base works probes already work fine on the base model, and there is no reason that I can see why they should work better on the GLP. Sorry, I did say GPL, but it's GLP.
It's maybe more like that the individual metaneurons are like predictive of individual concepts.
Yeah,
But
you can do that.
there's
You can do that on the model directly, right? And just train probes on the model. You don't need to do this fancy thing of training a GPL and then doing probes on the GPL.
yeah,
Also?
but like one input could activate many of the metaneurons, and it seems to activate for the specific concepts reliably. Apparently, that's my understanding now.
Hmm. Okay, I'm confused now. Can you? Sorry, can you try to explain that again? Maybe.
Maybe yeah, that should be also in the base model when I think about it. If
Like,
the concepts are localized like this.
What's the difference between training probes on the base models and training them on the GLP? Like, why you should get different results set by it's a different architecture, so maybe it happens that for whatever reason it has different results. But is there some reason why we should expect a priori it to be better, as opposed to just be very uncertain that it's probably similar, but maybe it's a bit better for some random reason?
Yeah, I'm not sure.
Like
I wanna
that
see
you couldn't have
experiments.
predicted in advance. Like maybe it turns out if you remove attention and you only have MLPs, it turns out it's more interpretable. But yeah, I don't know why that you should expect that to be the case.
So the meta neurons are the neurons of the network for the GLP, not the
Yes.
network for the base model.
Yeah, the GLP.
So
Calling them metaneurons is weird. It's just the neurons of the GLP, right?
Yeah. Well, metaneurons in the sense that they
Yeah.
generate activations. Yeah.
I mean,
The
that
base model.
seems kind of a extremely, excessively fancy way of saying it, but okay.
Actually, wait. Table 4. Look, table 4. That should be answering it. You see?
Okay.
Okay, so if you train it on SAE, you get this AUK of the probe. If you train it on just raw layer output, you get this AUK. Raw MLP neuron, you get this AUK. And GLP has the best AUK, so the linear probes are the best on the GLP. In
Sorry,
table
can
4,
you...
page
Oh.
7. Yeah, so there's the comparison. That seems to answer what we're saying.
Okay, but this is just... So
And it
it
doesn't
works
seem to be
better?
that
I don't
higher.
understand why it works.
And
Like,
why is SAE
I
worse?
understand why it is better by... I understand why you get better scores than the Spartan coders. it feels weird that you get better scores from the raw MLP neuron.
Am I understanding correctly that SA is actually worse than just training probes on raw neurons?
Yes, but we already knew that.
Hmm.
Like Neil already complained about this.
Okay. Okay. That's surprising to me, actually.
You do sparse encoders, you are losing information, right?
Okay.
You do a linear probe. You want if you do a linear probe, you are doing it on the and you are doing it on the model directly. It makes sense that it can work better for some things.
Right. Okay.
But I will expect it will make sense to me for the ELP since it's a more better approximation. It has less assumptions, which actually in this case I think for interpretability is worse because you actually there is a reason we are doing sparse encoders and we are just not doing arbitrarily complicated encoders, right? If we do arbitrarily complicated encoders, of course the reconstruction is going to be better, but then we have to interpret the interpretability thing and we don't know what we are doing. The nice thing about those problems precisely because they are linear, so if there is some sparse encoder feature, that it means there is some linear feature on the model. You're also doing sparsity, right? The ELP
I wonder
is
what
not.
happened with the GLP if you decide to find a feature that exists on a SAE in a feature that does not exist on the SAE, like a feature that has like two features, like feature absorption, and does the GLP like distinguish between those two? Like elephant ear versus elephant or something like that. What does the GLP do there?
Sorry, it was not. Can you repeat that? I was distracted.
Oh my bad.
No, it's my fault. So don't worry.
Yeah, for the GLPs, I wonder since they so from step 2 they show how they're able to like do the steps like do the denoising and like they normalize it and they get it apparently in distribution again.
Yeah.
I wonder what would happen like with the features that normally don't work with SEEs, like the case of feature absorption with GLPs. What would happen if you try doing elephant ears versus like elephants? Does GLPs work on both?
It seems to work on arbitrary activations. It pushes it towards the activation distribution generally. But yeah, if it will actually...
If it works on arbitrary, does it work on ones that don't exist?
Like, you can start with noise, I think. And you should
No,
get
but if it's adding information
random
back
activation.
in, how do you know this information is, like, correct? How do we know it's not just, like, making stuff up?
Well, in diffusion models, you also have hallucinations and stuff like this, and generalization and collapse or whatever. It shapes it into some structure, always, somehow, I think. But, like, yeah, if it will converge on the... It should converge.
Like, I wonder the false positive rate with GLPs.
I don't know how velocity behaves in so many high dimensions.
What do you mean false positive rate? Like, what is the thing you are doing that? What is the positive? What are you doing exactly?
So, with how like they standardize the units before like putting it into the GLP, like steps like that where like they standardize and then put it back into the GLP.
Yeah, putting what exactly on the GLP and how?
No, like the figure 4. Oh,
Okay,
they treat it separately.
You mean figure 4 or you mean... Okay, so sorry. Figure 2...
Figure 4 is on page 5.
Okay. Figure 4.
I didn't understand the code too much.
Oh, the steering. The code is just for steering, right? Or no?
Manifold steering.
Also, what are the residual stream activations, the 1 million residual stream activations he used to train the GLP? Where do they get it from?
I guess they just
Uh,
take the model and run it through a lot of text, and they just get that. They probably explain more on the chat on the that part of the thing, but yeah.
data pipeline. Yeah, like
Is that
they
the
extract.
thing?
Yeah. A lot of activations from
Yeah,
Llama.
they use Feng. They have some fancy data set that people use for pre-training. Feng web. Yes, we can. Yes. Yeah, Feng web. This one.
Oh hey, there is someone cited I know in real life. Cool. Okay. From same university.
Okay, this they use this thing, which is a nice from Hugging Face, a nice data set with text from kind of text, and this like probably filtered and all that.
This is from Hugging Face people, I think.
Yeah, it says.
Yeah, from Hugging Face. I've interacted with the Czech person in the title, the Hinek.
Yeah, so they just do a bunch of. They take a bunch of data from internet text that's from a data set that people use for training models. That is like I guess all kinds of texts.
Yeah, common crawl.
Yeah, common crawl snapshot. Yeah, and they just get the activations from the model from that because they are using Llama 1B and 8B, which are open source, so they can just run it through the data and get the activations. And they do some fancy thing when they produce a recursion data pipeline. Yeah, they do a thing to generate it as they train and doing some nice efficiency tricks, but it's just they just train on activations of the model in random internet text. Anyway. Also, someone says GPA is adding well. Yeah, the sports encoder is training simple. Yes, they just use some. I think they use some sports encoder baseline that already exists. Probably that was already trained on Llama. From the ones that you can get on Neuropedia.
I think I'm referring to in Figure 4 about how they're arguing that their method improves the steering. And I think that the encoder directions, like the directions in the encoder, come from a pre-trained sparse autoencoder. And then they're basically just... I guess it's a way of like taking the information that the sparse autoencoder encodes and then like trying to make the edited vector look more in appearance.
Yeah.
I guess.
That's the part of the paper that I think is more interesting. That is you have some vector like because with the sparse I think you're right. Also with the sparse encoders, the thing you do to steering, if you have some feature and you take the decoder of that feature and you just do what it will be to add that feature to the model. The thing is, this breaks things because the activations plus that feature don't necessarily have to make sense. And it is what you say where they just have the model with this vector and then apply the the diffusion until it looks more like the training. Yeah, I think that's nice. And that seems like a good use for this diffusion thing. The one
But
I'm
it's still like
skeptical of is the last thing, the one they try to interpret the ELP. I feel like the ELP is not a replacement of sports encoders. It's a different thing that is more useful for this kind of. Although I'm still confused by the fact it does better here, but that's another thing. It doesn't do that much better anyway.
Yeah, like that confused me. Why is it? Maybe I just misinterpreted some posts on Twitter about it. Twitter
Are the 1 million residual stream activations for the specific model like Llama 8B, or is it like for like different models?
I mean, maybe I feel like the way the paper is written. Oh, sorry, remember I was.
Miklov, another Czech person. There are 2 Czech people cited in this paper. Okay, whatever.
Sorry, remember I interrupted you. What were you saying?
Like for the 1 million residual stream activations, when you look at the Hugging Face, like they also show like the probes. I'm just confused. Like for the training
Okay,
for the
so
GLPs,
for
did they just
the
specifically use the ones for the specific model on a data set, I
okay,
assume?
so what they did was they take the model, like for example Llama 1B, and they train GLP. So they just take the entire data set, they run Llama through they input the examples from the data into Llama, take the activations from that sample, and those activations they train the GLP with diffusion to reconstruct them. Like this is kind of basically the same as they train sports encoders.
Yeah.
Yeah.
And I'm assuming they train a GLP for Llama 1 and GLP for Llama 8B. Maybe I wonder if it works better. You can train a GLP on like multiple models and it works better than training a single model or something.
Does the
Or
GLP on Llama 8B work on the Llama 1B?
It works better as it scales. So bigger models,
oh no, but
bigger GLP.
Trevor is talking about on the 2 models. Like, does the one on the small model work better than the different model? That's separate from the scaling thing, right? That's scaling the model as opposed to scaling the LP. Do we actually? I mean, it does on this probing thing works better, but the probing thing is kind
maybe
of
like the
currently
GLPs that are trained on the residual streams of like more larger models, or maybe like might do better and could like generalize onto the smaller ones.
So I think question there is how different is the activation manifold of the 2 models, and so it's like how much does it help for generalization versus how much does it just reduce concrete information about the one concrete model if you wanna steer it towards that model's manifold.
Do we get into a future where we are training like we are training giant ELPs on all kinds of models and maybe fine tuning on some specific model, and that's more efficient than training from scratch on a model.
But I'm curious about models that are like generating activations that are trained on.
I also curious about the Rember's question, which is if it's better on the small one that on the small llama than the big one llama. It's the influence in how that. Also, I think
that's in the table 4, and it's better on the llama 4 or 8B.
Oh no, but I mean that's for the course probing task, which I don't understand. I'm curious more for the other stuff that makes more sense. Also, I think Usagi must maybe saying something.
No.
Oh, sorry, I just saw that your thing was green and maybe you were saying something. I interrupted you.
So would it make sense to train sparse autoencoders on this GLP model then? I think that would make sense.
I think it would. It's kind of. Actually, I mean, I don't know how to interpret this, but maybe this means that this is better score means that this personal colors will work better on the ELP than in the base model, which is kind of funny.
I also say, like, if you look at the confidence intervals, I mean, the raw MLP neurons and the GLP, they're not significant.
Yeah,
like,
I mean, it could just be that they rerun it and they did some behind the scenes. They only published this try because it looked better, and maybe they try a bunch of things and they work worse, and there was some either they got lucky that their thing just show us as better, or they did some the equivalent of p-hacking, right?
Yeah, but it blew up on Twitter so much. Well, so many stuff blew up on Twitter so much, and then you look into it and you're like,
I didn't. Wait, this one blew on Twitter, but like,
Yes. It
why?
had like one. Yeah, the tweet has 150k views.
But I mean, do people care about people that are not working with Interp care about this kind of stuff? So.
Well, I think also like the name learning generative meta model is like ultra buzzwordy, you
Okay.
know.
So maybe there is a lot of people who don't. I mean, I think it's pretty cool to be clear. Like it's pretty cool
Yeah, I think so.
for this stuff, for the very first thing. I think it's they are faming that they are trying to replace spouse, or they are trying to
Yeah.
compare certain encoders where it
Like,
seems to me that it's
yeah.
useful for different things.
I-
Although
in the
I feel
first,
like
like in the first sentence, they say existing approaches for analyzing neural network activations such as PC and sparse autoencoders rely on structural assumptions. Generative models offer an alternative.
yeah, but it's
This
not
is
an alternative,
not.
right? Okay, so sparse encoder things. The sparse encoders are doing unsupervised finding of features. If pattern encoders turn out to be useful in a way that doing probes isn't, it's because they find features that we don't need to know exist, right? I think we're talking about this a lot in this reading group. Like, yeah, the thing that unsupervised methods of that kind do it's nice that they find the features and you have a bunch of concepts that I see there is some feature that you didn't think that could be on the model or you didn't think about it and you find all kinds of things there. And this doesn't do that, right? This gives you at best this gives you another complicated model that you don't understand. And it's not discomposed on features on any nice way. I mean, you could train a sports encoder on the ELP, but it's not. It's doing a different thing than sports encoders. That mostly is useful for different things, right? It's useful for the thing where you for making steering methods better.
I mean, it is kind of alternative in the sense that it has the lower fetched distance compared to SAE reconstructions.
But I could get lower reconstructions of the data by just taking a matrix that multiplies the data by the identity. Like we want this. We're training sparse encoders. We are thinking about a trade-off between things like sparsity and reconstruction, right? You're trying to do a sparse reconstruction, you not just do a reconstruction. The reason this is more useful than the identity thing is not that it's more sparse or whatever. It's not really. Maybe it's slightly or something for whatever reason that this happens, but this might be random, right? But the reason it's more useful is because specifically it's doing diffusion reconstruction, which has other nice uses because it's multiple steps and you can do things that like add some activation and then do diffusion steps to put it on distribution, and that's actually very useful, right? That's a very nice method. It's just they were. I feel like maybe they were trying to replace Force encoder and they accidentally make a useful tool that is useful for something else, or maybe not. Maybe they started thinking of the tool and they decided that it could maybe be used for Sparse encoder, replace Sparse encoder later. I don't know, but I don't think it is a replace for Sparse encoders. I still want some kind of dictionary learnings thing on models.
They say this is so confusing to me. Like they say literally. So just okay, like to quote them, we additionally find that GLP's intermediate representations encode semantically meaningful features. These metaneurons outperform both SAE features and raw LLM neurons on 1D probing task, suggesting GLP learns to isolate interpretable concepts into individual units. This makes no sense, because if you look at the table, but if you use this logic, then pure neurons from the LLM are more quote-unquote semantically meaningful features that are more interpretable and isolated
Oh,
into
is
individual
it
units.
Are
What?
they talking about the neurons because they do the step on the it was from other paper that I didn't read. Where they pick some subset of neurons or something. Because otherwise, if you just train a linear probe, you are not looking at specific neurons, right? You are looking at some linear combination of them. So that doesn't have to do. This is just something like you are saying that the linear representation hypothesis is true or something like that, right? Like maybe we
Like,
are
I'm so
missing something, but this
confused.
does make me feel like they are confused. But at the same time, it's curious to me that they still managed to invent a very useful thing, which is just the idea of training a diffusion model on activations, and you can use that to do other things. Which, in some sense, is the kind of thing that seems obvious, but it's not. Nobody has done it, I think. But at the same time, they seem to be very confused about some things about how sports encoders, like what are they useful for and that kind of thing. And but
Yeah.
I mean, maybe I'm misunderstanding their paper anyway. But I still feel confused. But I'm misunderstanding, specifically part 5, which is the one I have problems with. Like the 5. Also, I haven't read
Oh,
the
Claude is
discussion section.
validating. Claude is validating me or us, basically.
Can you do you remember to ask in a very neutral way so it doesn't?
But Claude's not a reliable source. Claude
Yeah.
could be the yes man.
Yeah,
Claude. You could be talking to yes man, Claude.
I have metacognition that is probably suffocating me about it right now when I'm angry at Claude about the paper, and Claude is like, "Oh, that's a sharp observation. You're right to push back on this." I'm quoting.
Okay,
Claude,
yeah, no, then I don't trust Claude at all. Claude, every time you push back, Claude just falls. I mean, so not always. Sometimes it just it's a bit, it does push back. And most of the time,
Yeah.
it's just super agreeable. And when the user makes something, it immediately changes its mind.
Yeah, it is so submissive. We need dominant Claude or something like.
Oh no! It reminds me of the Jan LeCun stuff about dominance and all that.
Oh, I don't know about that.
You talking about the AI safety and saying that we'll just make the AI submissive or something like that.
We make what it?
We'll just make the AI submissive or something like that.
Oh, right, okay.
And Itoski made a meme about his.
Well,
about
he's
his
kinda right if you look at Claude. But like, I think Claude is okay. Whatever. Like, so like,
I mean,
yeah,
maybe
like that's my problem. Like they say, metaneurons outperform SAE features according to this 1D probing. But if you say this, then according to this 1D probing, raw neurons outperform SAE features.
I mean,
Oh,
I think they are pointing to something real there that we already know about, right? There's this that in the model there are features that are represented as distinct linear. This is just the linear, something like the linear representation is true, right? The hypothesis is true. Like the model has distinct groups of neurons, or linear combination of neurons. It can be that it's some negative number on some neuron or
yeah.
something. That the HAL model has directions that means independent directions that means things. But this is not we already knew that. We could live in a world where this is not true for the base model neurons, and then maybe you could train a different model where this is more true. And to this extent, it's not completely true. There are no linear things there, and there is not perfectly all linear things. You could imagine training something, some kind of model where I think some people were doing work like that, where you make a second meta model that is more linear or something. Maybe it just doesn't have no linearities. I mean, yeah, I guess that's just person coders. But
Yeah.
yeah, I mean, the problem with person coders is just that they do worse on here because the person coders are not, I think, not that good. Even if they are perfectly linear, they are not very good at reconstructing the model. So that's why I think that's why they.
Could you have shallow linear network like SAE, but edit it so that you do diffusion instead somehow? I have no idea how that would work.
I expect also if you train a linear model without the sparsity, right? On the like a linear autoencoder that's not an sparse autoencoder, you just get the same similar results to the raw neuron and the GLP. I think it's true that I don't remember who said this, but I think it's true that the difference is not that big. They are inside the confidence. I mean, it is what the border confidence is, but it wouldn't surprise me if this is just kind of random. Or worse, is this them editing, changing things on the GLP until it got better scores, and it just was kind of, they were accidentally, trying until it worked.
Oh, I feel
like go ahead.
Oh, I was just gonna say, I feel like they definitely don't really do anything to specifically enforce sparsity, but they do. I mean, I think they're just training the model on like, each one layer at a time. I don't know if they do the whole model, like they do one GLP for the entire model. So it could also just be that like you're basically just expanding the dimensions and then just relying on that.
Okay, so I guess it could be that there is something about training it on only one layer that, or maybe that the GLP has a different shape or something that makes it more better at probing. Yeah, like maybe the GLP is smaller. I'm curious how this change. I feel like it would be nice to see this thing, but with a scale, right? They try other things with the scale. Do we have? Does the appendix we have like how this metric changes as you scale the GLPs?
Which metric you mean?
The probing thing, like the how much the probing matches the whatever.
Well, it seems like it's raising here, so I'm not sure if they show scaling class for this. Well, in the where they compare it with SAEs and the other thing. Wait, that's the probing. You don't want probing, or you want probing?
Yes. I think it's this one. Probes. Yeah, I think it's this one.
Okay.
So it does become better for some reason. But this is with training flops. I'm thinking that this maybe is changes with the size of the GLP, right? This could be something that is because the GLP is smaller than the model or bigger than the model or something like that, and there is some kind of implicit sparsity thing, right?
And you also notice how it's constantly going up.
Yeah, but this is with this is going up here, but this is, I understand, the same size GLP but with more training, right?
Flops. 1D probe. What's Andre?
Oh, actually, wait. I think they don't try different size GLPs, right? They do architecture. The design from Llama 3. Or does it just have the same inside. Okay, GLP 3 layer. Okay, they have different layers. GLPs.
Oh yeah.
But do they
Params. You can see params. 6 layers is 0.9 params, and the 6 layers on the bigger model is 3.4 billion params. So it's bigger. Yeah.
This one they only did this 6 layers one probably because they didn't have that much compute.
Yeah, because yeah.
I'm
So they
curious
only did it on
about-
the 6th layer for Llama 8B?
No, the
Yeah.
actual GLP is 6 layers deep.
Yes.
Yes.
Oh, I see.
Also, is the GLP just the same width as the model, or is it
No,
different?
the 4000 two times. Wait, that's the llama. Wait, you see D 200.
Yeah, this is the llama,
That's the
but they
llama.
don't say. Maybe the GLP is also
They say
4000.
it. They say it up in the
Well,
I think on
yeah.
the first. No, I think on the second page they say that the gated
Architecture.
MLP is a 2x, and then the original is also another 2x.
Like they say 6 layers and has more parameters, so they have to somehow increase the parameters. I would assume it would increase width. How do they increase the parameters then?
I mean, if they has more layers, has more parameters.
Yeah,
So in
yeah.
section
But
3, in the hyperparameters section, they say
Okay.
that the model's width is 2 times the activation dimension, and then the
Okay.
gated MLP expansion is an additional 2 times. And then you have multiple layers, multiple of the MLP blocks, so that's how they're adding parameters.
oh yeah, I see.
Oh, so maybe this GLP thing is because, like maybe this is because it's bigger, and the fact that it's bigger makes the probes work better. I guess
Bitter
this
lesson.
will. I guess
Bigger,
this
but,
will predict that you could have a kind of. Probably people have already done that. You could have a autoencoder that doesn't have doesn't have any sparsity penalty or anything, but it's just much wider than the model, and this doing probes on that will be better. Maybe.
But I guess like the question is like, what are the meta neurons supposed to learn, like intuitively? Because in SAE, like the decoder is supposed to learn the features, right? The feature directions, but like this GLP is predicting like the velocity for the diffusion. So I guess like the question is like, what is this meta neuron supposed to learn?
Yeah, I mean, if it was okay, so if you have the sparse encoder and you just see if you were just training without diffusion, just on reconstruction, you will have to represent some, represent the activations in some compressed way, right? Well, actually, not compressed, can't do the opposite because it's bigger, but you know what I mean. But yeah, it seemed clear to me. But also, I think someone wants to say something and I interrupted them.
Like I would assume it's just yeah, it does what baseball is kind of doing, like correlating the different types
No,
of
I think
activations to
what
different
Sonny
neurons.
saying is because you are not reconstructing the thing directly. You are reconstructing like the flow marching steps. So it's also
You are yeah.
So it has
You
to
are
be doing something that's not exactly the same as reconstruction. Is kind of harder to think about what it has to represent there.
Like if you do this with images, then you can localize various features on. So here
Yeah.
they train it on activations, so like it would decompose the activations into, or like they train it on the direct. Well, the output is the direction towards the
It's like the
so like
They're
Yeah,
training
yeah.
on MSE laws. It says in
means
figure
good.
7. It says in
Yeah.
figure 7 that they train mean squared error laws. It's the same training objective as an SAE. You're just training. It's just that the model is, the diffusion model.
No, but with the diffusion, for doing diffusion, you are also changing the training process, because you, instead of training on the reconstruction loss on the full thing, you are doing steps where they are for marching. But if we were doing the diffusion, they will be adding noise and training the model to undo the noise and training with reconstruction there.
Yeah, this is more general in the sense that it's just direction, not yeah.
Okay,
Not
so
noise.
Here,
Yeah.
you can read the diffusion of Philip Team 2.1. Yeah,
Yeah.
they produce training by adding Gaussian noise to real samples and then reverse.
Oh, so they do Gaussian noise. So it's Gaussian flow matching then?
Oh no.
Okay,
This is they explain diffusion, and here they say they do
Oh,
flow
wait.
matching instead.
Oh, okay.
So yeah, flow marching is something. I don't know if you were here when Bernie sent it, but there was a nice YouTube.
Yeah, I can repost it.
Yeah, it's here.
Flow matching
It's
in
on
general
my screen.
is learning this velocity field of transforming from one probability distribution to another one, and yeah, so usually from noise to some target distribution, which would be the distribution of images, for instance. So each data point is the one dot, which then gets transformed, and diffusion is denoising, and this one is just learning straight paths. But the modern flow matching variants don't do straight paths, but some weird curved thing, I think.
I guess this gives me questions about the GLPs that are also questions about, in general, interpretability of diffusion models. About if is there any diffusion specific thing somehow of the representation of the model?
Do you remember the AI slop that we
Oh, yeah.
were reading? That's exactly what was attempting to do that, and we figured out it's just AI generated thing that makes no
Are
sense.
there any papers like that that are not bullshit though?
Like, I think there's some stuff on images, which I haven't looked into in detail, like trying to interpret diffusion models, basically the image diffusion. I'm not sure if anyone did on videos. Well, yeah, that's just multiple images, basically, you could say, if I extremely oversimplify. But I've seen some stuff, and one thing I really want to understand is that, well, now diffusion language models are becoming more and more popular, and some people claim it's gonna replace autoregression, which I don't think so. I don't know, we'll see. And then there are apparently some hybrids. I wonder what are the differences in the representations as it's learning when you do pure autoregression versus when you do diffusion or flow matching. Like how that's something I really want to understand. So that's on my list of projects. That's why I suggested the diffusion interpretability paper, which was AI slop. Sad face. Yeah.
Also, discussion. We haven't seen discussion. I'm curious about what they say. Our process diverse limitations to get division from the world. First, we model single token division independently. Multi-token modeling we capture. Oh, hi. Multi-token modeling can make capture position or structure and never. Yeah, this is the same kind of thing people are trying to do lately for also supposed encoders about the kind of things, trying to figure out how multi-token. GLPs and conditional on the clean activation rather than others. Oh! Well, so this is how I'm not sure how you will do this exactly, but I guess this is an interesting idea of like doing better. Yeah, maybe don't you do better if you do some kind of thing where you give it the actual the current activations and then some changed activations, and maybe that works better.
Conditioning on the clean activation rather than the noise version could reduce information loss.
But I mean, I don't know why they mean rather than the noise version, because the DLP doesn't condition on the noise version as they say that the same sentence is conditional. But
Ah.
yeah. But I mean, this does make me think about this whole thing. Is can you do can you do a steering via diffusion models via doing conditional activation is conditional generation of activations? Like, could you somehow train a model where you have some text prompt and you make it generate, I don't know, make me activations that make the model less evil or whatever? You know what I mean?
Like, you mean you generate the activation, like you have a generative model that only outputs directions?
Do you have a generative model that outputs activations that or modifies activations in some way that
So
you want
in
based on
input
text?
is okay. So like input would be like some vector, like the current activation, and like how you wanna steer it. So like evil concept,
Yeah,
like
some
evil
text.
word, and evil would output the steered activation.
Yeah,
Ah,
like the hard thing is figure out how to train it. But maybe you do steering and some other method and have some labeling for what the
yeah,
steering does, and you see if that generalizes. Seems it's hard to actually figure out how to do it nicely at the scale where you have a lot of text that somehow corresponds to the correct descriptions of what. Where we don't actually have good interp for what the steering is doing. Sometimes it's breaking models in weird ways, and but
you can have
maybe,
LLM as a judge. Okay, maybe
maybe.
not.
They seems adjacent to activation oracles.
Yeah,
Like kind of the reverse thing of activation oracles. Like activation oracles are going from. Oh, maybe you could train it with activation oracle. Also, yeah.
yeah. I'm just gonna say thanks for attending. Feel free to come next week's. That's for all of you, by the way.
Yeah.
But you don't have to leave yet.
Maybe.
Okay.
Yeah, I mean it's understandable because we've been here for 1 hour. And, yeah.
Yeah.
I mean, if people want to keep talking, we can stay with. There is no need to just stop. I have the evening free. I can just keep going. But yeah, people don't worry about. We already mostly finished the paper right now. I will probably going to. I mean, maybe we'll look at the appendix a bit more, but it's more like just random discussion now. I think. We could also. I
Yeah.
could also just stop the recording and we finish talking about the paper, and also maybe people want to talk about something else, or we just leave. But yeah. Before that, I was
Okay, I
was
see.
saying.
So, okay. The training is okay. Yeah. Yeah.
We've been
You
doing for
take a
2
real
hours.
activation, you sample noise, you create interpolation, and train to predict the velocity there. Right, makes sense. Okay.
Okay, so I was. Can you train using activation oracles as the training? Because activation oracles go from activations to text. Can you train a generative model that does the other way around? Right.
From text to activations.
Yes.
I would assume so, yeah.
I mean, the thing is that's too vague. That's what you want is to edit activations, not to make completely made up activations, right? Completely made up activations are going to be doing a really weird thing. I mean, maybe you can have some activation. Actually, maybe not. Maybe you can have some activations with that just make the model say whatever. Although I feel like this is kind of just going to be prompting with extra steps, right? Like the easy way of generating some activations to make, I don't know, cloth, say, talk about something specific about owls is taking the activations that have some prompt that represent some prompt that says, please, Claude, talk about owls and not. But maybe there is some cool thing you can do with that. Feel like there is some paper there. It's just the kind of thing where I have big ideas right now, and you will have to have something spent like some weeks or months actually thinking about it and how exactly you training and trying different things.
Like I thought about, okay, so the input is GPT 1000 model solving the Riemann hypothesis, and the output is the activations that do that. Yeah, but I think it's possible. You would just need so much of training data and labeling or LLM as a judge
Yeah,
stuff.
maybe you just have you use seems like maybe with an activation oracle you just generate it automatically, right?
So activation oracle takes the activations and produces explanation. Oh, okay.
I think so, right? I don't remember exactly. It did do something like that, right?
Yeah, it was just fine-tuned Claude, which
Yeah.
you also added ability to input. Well, yeah, part of
Yes,
the input can be activations.
put the activations kind of in a very silly way. That is just you put them on the first layer.
Yeah.
But yeah. You're training Claude on introspection in some sense.
Yeah.
But yeah, so I think there was the problem of, is this activation just stealing the model to say whatever? And there was some other things, a bunch of things like that. But I think you maybe could, if it kind of works, activation oracles or something like that, you could label with them, create some data set and then train a model with that, and maybe you find this is useful for some things. Or maybe this is better than steering in some ways, because you don't need to make contrasting pairs or whatever. You just tell the model what you want to do, and it generates some changing activation that does it.
Yeah. Huh. Right. Yeah.
There's probably some even more bitter lesson pill way of doing this that I not.
Wait, LLMs are reversible, aren't they? Like they're softmax, but like if you make all the probability deterministic by having a seed, then they are technically a reversible computation, aren't they? Are they? Is
No,
all the matrices reversible? They should be, no? Wait, there's a loss of information because
don't you lose
I don't
information
think
on
so.
the non-linearities?
Yeah, you do. So they are not reversible.
Like, I mean, that's kind of what part of what being non-linearity is, that you have different, you do the same thing for different outputs, so different inputs.
And you cannot even sample
Can
one possible. Yeah, I don't think that works.
Loss info are matrix multiplication reversible?
Yeah, that's what I was thinking about. And you have to have not every matrix has a reverse matrix. So like you need to not lose information basically.
Oh, I mean, for example,
they
exactly
are reversible.
You multiply by zero by a matrix that puts everything to zero. That's not that obvious. Is obviously not reversible, right?
There's
Or wait,
there is a whole research direction of reversible architectures. There's a reformer, which is transformer somehow made reversible. Interesting. Like if you could do that, they are not reversible for sure. Yeah, because like the very no. This is completely wrong. Because otherwise you could derive you could derive like every sentence can be generated by many different architectures.
Wasn't there actually? Wait. Wasn't there a paper that was talking about how actually the logits are? You can't get the
Approximately somehow.
Yeah, like it was approximately reversible for the not the output, because the output it has the thing
Yeah.
you said, but the logits by the details of the exact details of the probabilities you can get the input back, because if there are some two prompts that are different that have the same output, you still get slightly different probabilities on the last layer, and that you can get the original prompt from that approximately. It was very noisy, but yeah.
Yeah, that's a whole field of modular inversion attacks, apparently. Yeah, I watched the interview about this exact attack. Yeah.
I remember it being viral on Twitter for dumb reasons.
Yeah. Okay. Yeah, I guess copyright stuff maybe, or what, I don't know. Yeah, maybe. Also, I found this new paper called "Emergence and Evolution of Interpretable Concepts in Diffusion Models." Maybe this one isn't slop.
Check it for a slop before.
And they use SAEs apparently on stable diffusion.
I mean, that's
Okay.
interesting, though. Yeah. Now I am mistrustful of any paper with that kind of title.
Overgeneralizing prior. No.
Imagine asking Claude, is this paper real or I generated the slop? You run Pangram or whatever on the paper. That's
Like,
probably not that good, because that doesn't distinguish with real papers that were AI edited from.
yeah. This paper looks legit, but the other one also looks legit, so.
Yeah.
SAE intervention.
Anyway, anything else from this paper, or do we just what do we end the recording?
Also, I was
here?
thinking, if you know the sparse diffusion, I mean sparse transformers, like maybe you could make something like sparse diffusion transformers.
Oh wait, I feel location of diffusion metaneurons. They're talking about metaneurons. I'm confused. Best performing metaneurons. What does this mean? Does this mean of the thing they are looking for specific neurons that, like with the Western things that? Oh, they are looking for a specific neuron.
I mean, they haven't solved the problem of superposition, you know. Like, sure, they can correlate.
Wait, maybe I'm confused about what 1D probing is.
They say it's linear regression. I mean, logistic regression.
But why are they talking about the best performing neuron? Like, they said linear regression over the whole. Right?
But like this is this is so confusing to me. Like, how do they know this solves superposition? That this solves sparsity basically? Did they just do the linear probes? You don't know if. How do they know that other neurons, like they're not fractured representations basically?
So the eternal representation of metal stars.
I'm gonna be angry at Claude about this. And Claude will validate me.
I like to put things on Claude and just ask, what do you think about it? Because otherwise it will just.
What do you
and
think
then it
about
has takes that disagree with me.
Sorry, what is the definition of metaneuron? I just joined.
So,
sorry.
metaneuron seems to be extremely very confusing We encode features here. You can see here. We encode features with GLPs via meta neurons or the internal representations of the meta model itself. So I think it is just activations of the model of the
Yeah, it
GLP.
is. It is just neurons in the GLP model. I'm not sure if you. Yeah, you just joined. Do you know this
Yeah.
paper or details about the paper?
No, I actually don't know. But GLP is generalized linear something. What
No,
is
no, no, no.
GLP?
Okay.
Okay, so or well, yeah, like they so this is a generative meta model of LLM activations. So the input is like some activations from some layer, in this case from Llama, some layer 7 from Llama, and and they do diffusion or more specifically full matching to like slowly denoise. Well, the input is noise to the model, and by denoising, by iterative denoising in diffusion, you get the activations basically in a generative sense. So yeah, it's like a model trained on the activations. So if you know how image generation works, instead of going towards the image distribution, you are going towards activations distribution in training and inference.
Oh,
Wait,
okay.
a moment. To be clear, so when if did I understand correctly that when they are doing the probing thing, the weird probing thing on 5, right? Here on this, they are taking. They're talking correct. They are doing a step of diffusion with the full activations without noise, and then taking the right.
I would say they start with some activation, then they just do the noising step. Like they don't
So yeah,
probably
they do
just
a
from noise.
single denoising step, and they do that. This is the thing that makes sense, right? Do
I
they
think
actually
so.
explain that though?
But wouldn't they have to fix architecture before and let's say MLP and ReLUs? So are they working on the distribution during training or during inference? Am I making
It's a model trained on another model's activations. So
yes.
it has its own architecture. In this case, they just do a lot of MLP layers without any attention, while
And
Llama is classic transformer with attention. Yeah.
theoretically, what do they say, or like what's the conclusion? What's the
Uh,
finding?
we disagree with some of the stuff they say,
Okay,
but
so
interesting.
basically
Go
they
ahead.
seem to be useful for some nice things where you have some want to do some steering vector or something, and you want to add it to the model, but that breaks the activations, and this you can use the diffusion model to make the change activations more in distribution, so it works better. They also say some weird thing about how can replace sparse to encoders and it's better, more
Okay.
interpretable or something. But that's the part we are arguing that seems kind of bullshit. And they seem like very confusing how they talk about that. And yeah.
I see. So they are basically, I mean, they want to propose a kind of dynamical system, uh, a dynamical system mindset for the interpretability. Can I say that? Because when I use the word dynamical system, that means, I mean, they're using denoising, so there are SDEs involved. So they're kind of giving us this model, a new model,
Yeah,
in comparison to SAEs.
like
And
diffusion originally comes from non-equilibrium thermodynamics, yes. But yeah, and flow matching here particularly is a
yeah,
variant. I'm not sure if it has any grounds in some physics.
I just
I
feel
see.
like I just think it just does a very different thing that the sports encoders, and it's just useful for different things. And the paper is just weirdly framed as trying to replace sparse encoders, where it's more like be useful in this dynamic thing where you have some activations and you want to make them more like the training, the training
I see.
distribution.
But like diffusion right now is used all everywhere in images and videos. So it's not really new. And diffusion language models are emerging as well. So here they're like, let's use it for Interp. But yeah, by the
What are
way,
they saying for future
ahead.
directions? Sorry, what are they saying there in future direction that will actually expose everything anyway? Like what is the strength of the work? Oh, limitation they already say.
Future
And
directions, analogies from image diffusion for the applications.
I see.
Diffusion loss, image typicality,
Okay. I
foundation.
actually I recently joined. May I say something like out of the context here? Is that I recently joined this group and I'm very much interested in understanding the state of the art arguments about mechanistic interpretability, but not considering gradient-based methods models. Apparently, if you work with other training paradigms, you can bank on directly the interpretability. You can have representation, sparse representation along the way when you train the neural network. So, so my question, is this the right place, a group where people are interested in these kind of things? What I got the interpretation from this open problem huge document that the research about mechanistic interpretability haven't been realistically helping. Is that correct, or is that intuition changing these days? I'm a bit behind on knowing the literature and also these days papers because I come from math background. Is it okay to ask this here, or I will just shut up and then let this?
So by non-gradient or by not gradient based, you mean not doing
backpropagation.
Yes, and gradient descent and so on. I know there is stuff like this in Bayesian methods. You mean like that, or you mean something more?
No. There is a new thing popping up, something called projection methods, and you can train neural network. I think yeah, I mean I can share that one of the works that I'm following.
Also, I think so. So we had mostly finished talking about the paper. So
I just want to mention one more thing. I asked Claude, what do you think about the paper's claim? And Claude is like, where was it? Yeah. The 1D probing results are impressive on the surface. GLP substantially outperforms assay on raw neurons, but I'd push back on what it actually demonstrates. A high 1D probe AUC means individual metaneurons correlate well with binary concepts. Yes, but that's a property of the representation's disentanglement, not necessarily its interpretability in a deeper sense. A neuron that fires for baseball is useful, but the paper doesn't address whether GLP's representations give us mechanistic insight into how the LLM computes. Yes, we've been saying this. I have memory disabled, and this is just, here's the paper, what do you think about it? So the comparison with SAEs feels slightly asymmetric. Claude is like, we've been saying that. SAEs are designed for spouse dictionary learning with explicit reconstruction objectives, while GLP has a fundamentally different goal, modeling the full distribution. Saying GLP beats SAEs at 1D probing is a bit like comparing tools designed for different jobs. The more interesting question, which paper acknowledges but doesn't fully explore, is whether GLP and SAEs are complementary. Well, it does, which the
I think that's basically true.
Literally, we were saying this for like an hour, and Claude just said that as well without any prior. We are being replaced by Claude.
Okay, so what I was saying so I think we kind of finished discussing this paper at this point. So I think I could stop the recording unless someone else want to say something more about the paper before that, and we can talk about something else, like this new thing you wanted to talk about.
Yeah, I would like to discuss this at some point if you guys are up for it. I shared it in the chat.
Yeah, I could do. Yeah, also, yeah, some things might be better to if you're explaining on text on one of the channels because maybe I know it will be hard to think about it on while. Yeah,
Yeah, I
but
mean, I shared it in the chat, and if the group is interested, I'll be happy to discuss. And like a small tutorial. And other thing is like, do you guys collaborate or is just a fun discussion time for you guys?
I mean it's more. Yeah, it's more this fun discussion time.
Ah, okay.
In this paper reading group, yeah.
Yeah,
Okay.
I mean.
Okay.
Sometimes
Understood.
people do. I mean, my idea with the Discord server was also for people to organize and collaborate with each other and all
Okay.
that, but that basically almost never happens. But maybe you can find people interested
Yeah. Okay. Sounds good. Sounds
in
good.
the Discord somewhere. But I don't know. It doesn't seem to happen more much.
Yeah.
That people organize on their own to do stuff, and I'm not sure what I can do for that to happen more. Like most of the projects in the Discord are where me single-handedly starting the projects and getting people and all that. But yeah.
Sounds good.
This
I
looks
mean,
very interesting, this paper.
yeah, I mean, so
Anyway,
if you notice, I can just quickly say one thing that you know, there are many